Correlation using Pearson's product moment. Here we are going to measure the correlation between hours of study represented by the letter H and score represented by the letter S via a tool or method called Pearson's product moment. We will obtain a descriptive measure, which is a statistic with a value that will be between -1 and +1 inclusive, as indicated in the following scale. If you get a value of -1, that will be perfect negative. If you get a value of +1, that will be perfect positive. Any value between 0 and 0.5 will be weak positive. Any value between 0.5 and 1 will be strong positive. Any value between 0 and -0.5, that will be weak negative. And any value between -0.5 and -1, that will be strong negative. So here are the values we're going to use, the data values that we are going to use to calculate this statistical value, if you want to put it that way. Hours will be the independent variable represented by the letter X, and score will be the Y variable or the response variable represented by the letter Y, sorry. And R now is the Pearson's product moment correlation. Here's the formula. In each term in the formula, sigma is present. So just to remind us of the order of mathematical operations, you do what's in the bracket first, then the exponent, then you multiply, then you divide. Then we use S for subtract, and we use sigma for sum. So it's like BEMS. So it's like a modification of BEMDAS. Sigma for sum, you always sum last. Anytime you see sigma, do all what's to the right of sigma first, and then you sum last. Here's a simplified version of R. A will be the first number, subtract the second number. That will be n times the sum of xy minus the sum of x times the sum of y. That will be A. B will be the third number minus the fourth number, n times the sum of x squared minus the sum of x all squared. And C will be the third number, which is the fifth number minus the sixth number, this n times the sum of y squared minus the sum of y all squared. To do this calculation, we are going to use Excel to help us. Here we have the values inputted in Excel, the X data values and the Y data values, because it's very important to distinguish between data values and statistical values. So try to refrain from just mentioning the word value. What value? Data values or statistical values? So here are the data values, and we're going to calculate a statistical value called R. So to do that, we need to find xy first and then find the sum. Remember, we have to sum last. So to find the xy's, we type equal, and the first x is in A2 times the first y, which is in B2. Enter, and then to get the other xy's, we simply double click in this green square to the lower right corner and hold and drag till when we reach C8, and these are the sum. These are the xy's, and then Excel find the sum thereof by using the sum function, which you can get in AutoSum, edit, and just type sum. And here we have the sum of xy. Now to find n the sum of xy, n is the number of individuals interviewed, the number of pairs of data values, 1, 2, 3, 4, 5, 6, 7. So n is 7. So here now we multiply 7 equal 7 times the sum of xy, which is in C9, and you just type enter. So here's n times the sum of xy, that's the first value. Now we need to find the sum of x times the sum of y. So we have to find the sum of x first. So it's simply x alone, so we just find the sum. We click where we want Excel to put the sum of x, which is in A9. You go to editing, and you type AutoSum, sigma sum, and here you have the sum of xy. Now, the sum of x. Now, to get the sum of y, we can simply go to that very same lower right green square, double click, hold, and drag, and the sum formula will come. And as you click on it, you will actually see the sum of B2 to B8. That's the sum of y. And here now, we can easily type equal the sum of x is in A9 times the sum of y, which is in B9. We can do it again, equal A9 times B9. This will give us the second number, the sum of x, minus the sum of y. And as you can see, we get A, the first value, one time. N times the sum of x squared. We need the x squared first to find the sum. So we just type equal, and we type on E10, and we raise to the power of 2. That will give us our first x squared. And to get the rest of the x squared, we just double click and hold and drag, and automatically we have pre-programmed the sum of x squared. Here it is. And here, if you type here, you can see 7 times d9, 7 times the sum of x squared. Now here, we need to find the sum of x all squared. So that's where we're going to put the sum of x all squared. The sum of x is in A9. So as you can see, it's A9 all squared. So that's the sum of x all squared. Now we need to find n times the sum of y all squared. Now the sum of y all squared, we need to find y squared first. To find y squared, we type equal in E2, and the first y is in B2. We type B2, click on B2, and we raise to the power of 2. That's the first y squared. To get the rest y squared, we just double click on this green square, drag it to E8, and this is the sum of y squared. And here we multiply n times the sum of y squared, 7 times E9, and that is n times the sum of y squared. Now the final number, which is the sixth number, the sum of y all squared. If you click on it, you can see now we have, this is the sum of y, which is in B9, and it was all squared. So this is the sum of y all squared. And these are the 6 numbers. To get A now, A is n times the sum of xy minus the sum of x times the sum of y, which is in B10 minus B11. And as you can see, B10 minus B11, that will give us E. B is the B12 minus B13, which is n times the sum of x squared minus the sum of x all squared. And here it is, B12 minus B13. And C now will be in B14 minus B15, which is n times the sum of y squared minus the sum of y all squared. And here it is, B14 minus B15. And R now, as you can see, is A divided by the square root of BC, which is in D10. A is in D10, so you type equal D10. Right, it is A divided by the square root of D11, which is that's where B is, times DC, that's where D12, that's where C is, and you get 0.98. Now to verify if we have calculated this properly, we can use Excel itself, because Excel have the Pearson's formula pre-programmed. So you can just go to formulas, make sure you click where you want Excel to put R for you. You go to insert function, and you go to statistical, and you look for Pearson's. Make sure this is in statistical. Right, and you look for Pearson starting with P, because these are in alphabetical order. And here's Pearson. You just click on Pearson, you click OK, and you indicate to Excel what are your X variables. Your first array of numbers is from A2 to A8, and your second array of numbers is from B2 to B8. And then you just click, and here it is, 0.982, 0.9825. And this is a verification that this is the correct value for R. For our working, we can simply use snipping tool. Snip this here, make an image of this. That's our working using Pearson's product moment. And we go to our Word document. And then you can clearly see that as a conclusion, 0.98 is between 0.5 and 1. It is very close to 1. And it's a positive number, so that's a strong positive correlation. So therefore, we can conclude that according to these 2 samples of data values, there is a strong positive correlation between hours of study and score, because we found the statistic to be 0.98, a coefficient correlation statistic to be 0.98, which is very close to 1. In other words, the more time you spend studying, the most likely that your score will increase according to this sample of data values, because we have found a statistic, a product, Pearson's product moment coefficient correlation of 0.98.